Hey everybody, this is Mr. Folly. Oh, isn't that special right there? That's got a good sign here. Hey everybody, this is Mr. Folly, and welcome to Podcast 7.3, where we're going to talk about the energy in reactions, which typically we'll see as heat, but it can also be light. We're going to talk about endo and exothermic reactions, and we're going to use LOL diagrams. Let's change that slide for no reason at all. Exothermic. So something is exothermic. The prefix exo means out. Heat is coming out of reactants. So heat is released. If you touch it, it will feel hot. More bonds are forming, and the products have less energy. Stop changing slides, please. So if I start off with my reactants and they have yay much energy, and energy is coming out of it, right, out of the reactants, that means my products will have a little bit less energy. Okay, so the products will have less energy. So this could be the part of an LOL diagram to start with. Let's see this guy right here. Reactants. Here's energy. Oh, here's lower energy. That's exothermic. Okay. Endothermic. Heat is absorbed. Now, it could be energy. It doesn't have to be heat, but its energy is absorbed. So if you touch it, it feels cold. So if I stick my finger on this thing, it's going to absorb heat from me. I guess my big toe, that's what it looks like. It's going to absorb heat from me, and if it takes away my heat, I'm going to feel cold. Brrr. Okay. And when that happens, more bonds break because it absorbs my energy to break the bonds. And the products would have more energy. So see how I start with the reactants? If I absorb energy, my products will have more energy. Okay. Make sure this is in your notes. Make sure this is in your notes. Make sure this is in your notes. Oh, that reminds me, I want to do that one too. And then, so if I have reactants, and it's going to have more energy, so if it's endothermic and it absorbs energy, whoa, look at all that energy I absorbed. Right? Adding heat to NH3 creates N2 and H2. So I'll write it for you. Whoa! NH3 decomposes to form N2 plus H2. Sorry, I drew an equilibrium arrow. I didn't mean to. Just a regular old arrow will do. Arrow. Okay. So I'm going to start off with, when we do these, I like to start off with them just kind of in the middle. Energy, we are not going to do anything with phases this time. Okay. Oh, please stop changing slides. Okay. Okay, so what's going to happen here is adding heat to NH3. So if I'm adding heat to it, energy has to go into it, right? And if energy is going into it, that means my products will have to have more. Now, it does not get hotter. It is the same temperature. It is the exact same temperature. So if it's the exact same temperature and we're not really doing anything with the phase change, then that means my chemical energy must be more. Does that make sense? Okay, so again, I add energy into it. One of these two things has to go up. Since our temperature is not going up, then the chemical energy must be going up. And if I'm doing an energy curve here, I'm going to start with my reactants, and the energy is going to go up, and I'm going to have products, and this is energy, and this is time. Okay? Sorry, this line is here. It shouldn't be. Adding heat means thermal energy, so ETH goes from high to low. Oops. The energy changes from low to high for this because the energy has to equalize. Now here, the thermal energy, even though we're adding heat, the thermal energy, heat means thermal energy converts to ECH because the temperature isn't going to change there. Okay. Methane burns. Methane is CH4. If something burns, remember that means it means plus O2. And that's going to give me CO2. Hey, it's combustion. I know these products. Plus H2O. Now when you burn, it releases energy. Hey, look at that. There's energy releasing. Okay. So again, I like to start with my middle. Get back here. Get back here. And middle. And I'm ignoring this guy. Okay. So if it's burning, what happens is it's releasing energy. Right? So if it's releasing energy, energy is coming out of it, and if the thing stays, get back here, the same temperature, then its chemical energy must have gone down. Okay? Combustion reaction releases heat. If heat goes down, then ECH must go up because temperature is the same. Temperature is about constant. Okay? So my energy curve for a exothermic reaction means I'm going to start with my reactant and it's going to go down to my product. So this is my energy and this is me getting mad. My slide keeps changing for no reason at all. Like that. And this is time. Alright, so heat released means the word heat is a product. So if I go back here, heat. And if I go here, adding heat means I have heat plus NH3 yields N2 plus H2. Okay. So the word heat released means add the word heat to a product. So reactants yields products plus heat. Heat absorbed means the word heat is a reactant. So heat plus reactant yields products. ETH and ECH will change, but EPH we're going to ignore. So our thermal energy, we're not even changing that one really. We're talking about where the temperature comes from. The chemical energy will change based on absorbing it to heat. Graph going up is endothermic. Woohoo! Graph going down is exothermic. Woohoo! There you go. That is it. And I will say toodles. Come on, toodles.